GLS is turning on cameras, recording video inside and outside the crew module to collect data for engineers. Purging the aft skirt booster with high flow nitrogen. Clear out any hydrogen gas that may be there. You can see the crew access arm is already retracted. When there is crew during Artemis 2, it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff. Want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. You'll see that sequence start at T-minus 17 seconds. Now coming up in less than 30 seconds, the ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization. Firing room 1 is completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
The core stage tank is now pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing. The liquid oxygen tank will come a little later. Now we're arming the Orion ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
GLS is go for FTS arm.
The flight termination system is now armed. Coming up at 4 minutes and 40 seconds, a big moment. This is where the RS-25 engines and their bleed go to high flow. It's been a little tricky to dial in.
GLS is go for LH2 high flow bleed check.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus 4 minutes, 15 seconds. Up next, GLS fires up the KPUs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage Auxiliary Power Unit Start.
GLS is go for core stage APU start.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage. At T-minus 3 minutes and 10 seconds, you will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
GLS is go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen. The white vapor cloud caused from the super cold gaseous oxygen condensing the water in the atmosphere will disappear. You see it coming out there now. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels. Coming up, In 15 seconds, look for that thrust vector control actuator test. Engines will gimbal. And there they go. The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space. They will operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. Altogether with the boosters, 8.8 million pounds of thrust.
GLS is go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS is go for core stage to internal power.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2
GLS
seconds.
is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing
15.
under the ML. And here we go.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. Core stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter. Confirmation that the solid rocket boosters have separated, these 177-foot boosters. Now the core stage continues to power the flight of Orion, all four RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange. 2 minutes and 36 seconds into the flight. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation. Just over 3 minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated. And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members, we just heard the call for 3-engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange. We're 4 minutes and 16 seconds into the flight of Artemis 1. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis 1, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good. Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are now 5 minutes and 11 seconds into the flight, 7,656 miles per hour. Again, 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight. 5 minutes and 42 seconds into the mission, we are now traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center. Again, we are anticipating core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis 1, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight. About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire at maximum thrust. Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control Houston. As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down. "30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down. Now 7 minutes 45 seconds into the flight, traveling over 16,000 miles per hour. Continuing to hear good calls here in Mission Control Houston. We're standing by for core stage main engine cutoff. And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit. The flight dynamics officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System. The next milestone will be solar array deploy approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear the rocket roar off the launch pad. Megan and Kayla, I've got to hear all about it.
Well, if you're just joining us, welcome to NASA's Kennedy Space Center, where we just watched Artemis 1 launch, our first step towards our next adventure into deep space. As Leah said, I'm NASA's Megan Cruz, and this is NASA astronaut Kayla Barron. And I'm kind of still giddy and speechless. I don't even know how to explain how I'm feeling right now.
I feel the same way. This is the first launch that I've been able to watch in person. And I've got to say, it was incredible. It took my breath away and I was tearing up. Just what an amazing accomplishment for this team, this international team, people who have been dedicating their careers to getting this rocket off the ground and taking the first step to getting a crew on that vehicle back to the moon. It was just incredible.
Yeah, this is a moment I think that we're all going to remember where we were when we saw this sort of thing, you know what I mean? And it was great to see, again, when we entered into terminal count, everybody here just started cheering, you know, coming out to get a really good view. And boy, I mean, it lit up the night sky and it just shook everything around us. Did you feel that? Like in my bones, I felt that.
Oh yeah, the cool thing is just kind of the delay between what you see and what you hear, because of course the sound travels a little bit slower, and it was just amazing. The ground shook. We could hear the thrust pushing that rocket into space. 8.8 million pounds of thrust.
Yes.
It's incredible. It was amazing to see here live in person.
How does it compare? So this is your first launch on the ground. How does it compare to your launch when you're in the capsule soaring towards space?
I mean, equally emotional, I think.
Yeah.
We train for everything, and so when we're in that capsule waiting for launch, we're just running our procedures. You could almost, you know, trick us and say that we were in the simulator and it wasn't real, but like in that moment of liftoff, when the thrust builds underneath you, like we saw it today, it's just hard not to be overwhelmed by the emotional experience, the excitement, the joy of that moment. It's incredible.
Yeah, I think we can't say it enough. This team really deserved this moment. They've been working so hard for this moment. When I heard that we got into terminal count, it was, I felt a sense of relief and excitement for them that I think everybody here did. You know, we really wanted them to succeed. We really wanted to see the launch today. And wow, I will never forget this.